today and tomorrow are the last things that we do as part of this quote-unquote unit that, like, how CPM lays things out. Then the next thing that we do is go back to the CC2 book, but in chapter 7. What? Right? Because the content that we've covered in the CC3 book kind of leapfrogs us through the CC2 stuff. So that's the reason that we're going to be going back and forth this year. Is the books cover the same material. It's just at a different depth. And like how, well, I was going to repeat myself really and just say how deep you go with it. But yeah, I mean, that's really what it is. So like, you know how to add. Then you add decimal numbers. Then you add fraction numbers. Then you just keep getting better at adding. And you keep going harder at, like, that's what all math is. You know how to multiply. Then you multiply with like binomials, which are two numbers that can't be put together. And then we work with quadratic trinomials. And like, yeah, but we're not there yet. But I'm just saying, like, that's math just keeps layering on. So today we need graph paper out to take notes. By the way, that's what math binder means up here. If you keep your graph paper in a binder, if you just pull out your math binder, that will help you stay really well organized. And I know some of you have figured that out. Apparently this remote got broken yesterday. I mean, I don't use it, but... So, today we are still working with equations in the form of y equals mx plus b, but we're also going to be working in a different form. So as you see up here, if you're looking in the book, it has that line, and we talked last week a lot about y equals mx plus b, but now we're going to be working in what's called standard form. And we haven't really used the equation mat. I think we maybe wrote one, this, on like a piece of notes one day when we did this. But if there's Chromebooks available, because I did not plan well enough to reserve them, so I got to check if there's Chromebooks available. We're actually just going to do this in a Chromebook activity, but we'll get to that later. So, yeah, we already have been talking about all these questions, so we're just going to dive into 5-1. All right, so anyone want to read that, or you're going to have to listen to me? Mallory, let's give you a shot today. Go ahead with 5-1.
You now have a lot of experience working with equations that compare to quantities. For example, while working with the height of a tree, you found the relationship y equals 4x plus 5, which compared x, the number of years after the answer, with y is a and b. Use the equation for this tree to answer the questions below.
So, take a moment with your team real quick. These should not be hard questions if we paid good attention last week. What's the original height of the tree? What's its starting height? And then what is its growth rate? And then we'll ask the question, when you go off to college, which is, like 5 years from now, how tall will this tree be? Apparently my smartboard is struggling this morning, so I'm going to see what's going on with that. How tall will the tree be 5 years from now? Interesting. It won't let me scroll, but it will let me do everything. Aha! Maybe I just needed time to look up. By the lack of conversation, I am guessing that not many of you need to check with anybody about this. Mr. Wilson, actually that doesn't work because there's two of you. Micah, what is the original height of this tree? 5. How do you know that?
Because in the equation, whatever, it says 4x plus 5, so that means it starts at 5.
Yeah, and it means that, I don't know if we've explicitly talked about this or not, because if I plug in x of 0, like when the tree's planted, x is 0, 4 times 0 makes 0, and then we just get 5. So then, Peyton, how do I talk about the tree 5 years from now? Okay.
So after 5 years, it will go 4. It will go 4 each time. So it's 4 times 5 plus 5.
So what Peyton just described is this. That plus sign. Sorry, I think I need to reorient my board. But we fill in the number of years that we've been given, or the x value, right? Or whatever x is representing in the terms of the problem. We fill that in if it's been given to us. So now we're going to work with something called standard form. Standard form, I don't quite know why it's called standard form, but it is not slope-intercept form. So the two forms that we have, and I'd like you real quick in your notes to write out that this, y equals 4x plus 5, how this is written, that is slope-intercept form. Yeah, can't write today. That's different than standard form. So then, maybe do like a little squiggly or something that we're changing gears. Standard form is written like this. So if you could go ahead and copy that into your notes and write standard form. What's different? Obviously different numbers. It's a whole different equation in general. But Quinn, what do we notice?
The y is now in the equation instead of y equals.
Yeah, y's not alone anymore.
Y is in it to win it.
It's in it to win it.
It shows us the answer.
Yeah, it kind of like shows what the answer, quote unquote, is. It's like this thing, the negative 6x, plus the other thing, 2y, makes 10. And, well, we know what 10 is. We don't know negative 6x and we don't know 2y, but we do know 10. So, to get this back into slope-intercept form, we can do some stuff with it. So, if we have an equation map, our equation maps show us two things. Well, really four things, I guess. Our equation map shows us a left side and a right side. And we are actually going to be working with digital equation maps. So if we can grab some Chromebooks. But I wanted you guys to be aware of this. Regardless, even if we can't get Chromebooks today, you can access those whenever you want. I think you can just search the tool. I forget what it's called. Equation Mat E tool. So if you're looking for it in the digital textbook, can you set up, please? Thank you very much. So we have positive 2y, negative 6x's, and then equal to 10. Right, so my left side is going to be equal to my right side. That's how the equation map works. Any questions with this? We just put positives, negatives equal to the other positives. Cool? So then we start to manipulate. Right? If I want to, I don't think this is set up anywhere. So I'm, what was it? Negative 6x's. 2 y's, and 10 ones. These can stack on top of each other, so be careful if you go to do this. Oh, how many is that? 3, 6, 7, 8, 9, and 10. So, last year I kind of went too fast with this, so I want to make sure. Do we all understand that all of this stuff over here is equal to the 10 right here?
Yeah.
So now, if I were to take 1 away from this side, what would I have to do to keep this mat true and actually equal? Mallory? Take 1 away from that side, can I? No, I don't have any 1 tiles. Shoot. But if I want to figure out what y equals, right, I want to get this back into standard form. So we're going from the negative 6x, positive 2y equals 10. I want to get all the way just to y equals. Can I remove, if I want to get y by itself, can I get rid of all these guys? Connor, you got an idea?
I'll take away half from all of them.
I agree, but hang on to that idea. I'm going to come back to you. You're one step ahead of me. Now this is where math gets funky because you have to like step outside of the physical, real, what can happen. To get y by itself, I need to get rid of these 6x's, right? But if I remove these 6x's, I'd have to do the same thing on the other side. Now I can't remove 6x's, right? Because there aren't. So instead, and this, I'm actually in a conversation right now with a gentleman online about how to teach subtraction to middle schoolers because it's a weird concept. I can't subtract 6x from over here, but could I add in a negative x and start to destroy the x's over here by bringing in the opposites? So instead of thinking of this as minus 6x, which I can't do over here, we're going to add in sorry, and these aren't positives though, right? These are all negatives. And this is where I don't love the equation mat. And let me explain why. These are all negatives even though they're blue. Because they're on the negative space of the mat. If I want to actually see them looking like negatives, I need to bring them up here and do this. When you tap one of the tiles, it becomes the other, like the opposite. So if it's positive, it becomes negative. So I don't need to actually add negative 6x's. I need to add positive x's, right? Sorry, I know I was explaining that poorly because I was looking at them as positives. My brain got stuck. Those are negative. It's a negative value, right? So to get rid of the negative 6x, I actually need to add a positive 6x, which I can do. This is set up easier because I can do that, right? I can add positive x's all day long. So if I add a positive x here, that'll destroy this one. If I add a positive x here, that'll destroy that one. And I do this 6 times to all of them. So then, what does that make happen? I add 6x's over here. So what we write out, and what you want to write on your paper, please, is we add 6x to make this become 0. But I also then have to add 6x over here. Now, I still don't have a single y, but I'm getting closer. Those all destroy each other. And then I also have now, do I still need these up here if they all destroyed each other? Did I? Sorry, because I can't count. Sorry, it is hard to be up here and keep track of everything necessarily. So all of these, since they destroyed, we can get rid of them, right? They are zeros. I'm going to move them because I don't like being more complicated than I need to. I now have the equation 2y equals 10 plus 6x, but that's kind of gross. I'd rather write the x first. So 2y equals 6x plus 10. Now Connor knows how to take this home.
Oh no.
I don't have what I want. I have double what I want. Right? I want y, but I have 2y. So Connor, you had said we do what? Just half everything. So if I split this into 2 groups, And I say, okay, I'm actually going to look at what is an individual y equal. I'm going to split this into two groups. So, okay, x over there, x over here, x over there, and there's not enough space, x over here, x over there, x over here. Then my ones, I got to split my ones, right? 3, 4, 5, 1, 2, 3, 4, 5. Now I've split this into two nice little groups. What does a 1y equal? And ignore that I'm writing this in the mat. I guess I have nowhere else to write. How many x's? 3 x's when I split it, plus 5. And we show that division by 2 on this side, division by 2 on this side. Does that make sense? Now, we could have divided when Connor told me to, like back a couple steps ago, but it actually would have made things a bit harder for the rest of the problem. You normally wait till the last step to do a division if you need to. Okay, we normally wait till the last step. I want you guys to try this with this one. Now I know it's a bit more complicated, but try that with, so now we're on 5.3 part A. I want all of us to try this one together, then we'll kind of split things up. So you have 2x and a y on the one side. You have a 3x and 7 negatives on the other side. So before I even ask about it, do we even now fight your urge of oh, computers, yeah. Do we even need to do the e-tool, or can we just kind of physically work through this on paper? Because I think getting on Chromebooks, getting to the e-tool and everything else is going to be such an investment of time. I don't really think that we need to do that, because I think we can probably comprehend this pretty well. Here's what makes solving equations so darn hard. There are 4 correct initial choices here, and if I look at everything, there are actually 7 different choices that I could make right now that all could lead me in a correct direction. The strategy of solving equations is decide how to make your life the easiest. Would it be easier to move the y over here and then try to get these things over there? Or would it be easiest to leave this guy b and get rid of this 2x? Get rid of the 2x, right? Because this y can have the left side if he wants it, right? He's already over there, or she. I don't know why I give numbers, male, genders. I don't notice that recently, and I should stop. But so y's got that side on lockdown, right? No need to move. Just get rid of the 2x. How do I get rid of a positive 2x? I heard both, and I love it. You can either think of it as adding a negative 2x, or you can think of it as removing 2x's, because we can do this. Now, if we didn't have any x's over here, I'd probably advise adding the negative, right? Adding the opposite, because physically, we couldn't remove any x's if we didn't have any, but we do. In this one, we're lucky we do. We can remove them, or you can think of it as adding the negative. But now, y still got that left side on lock. What's my right side become? X minus 7. I can write the 1 in front of here, or I don't have to. Why would it be convenient to write the 1 there, George? Who got confused last week on the homework when I asked what the growth was and there was no number in front of x? And then you had to realize either you skipped that problem, didn't do it right, or you had to realize and tell yourself, and I think we talked about it in class, I don't talk to Jessica by saying, hey, 1 Jessica, how are you this morning? I just say, hey, Jessica. I don't say, hey, 1 Teak. We know there's 1 Teak and 1 Jessica and 1, we don't have to say 1. That's redundant, and mathematicians don't like redundancy. Because mathematicians don't like redundancy. Because mathematicians don't like redundant, right? It gets you out. Mathematicians do not like redundancy. Now, here's the one other option you have with writing this. You could put the 1 or not put the 1. And then We could even change this to addition. Plus -7, because if I want it to be back in my nice y equals mx plus b looking form, I'm used to this being addition, right? But either way is right. You just have to be able to tell yourself, my starting point is not 7, it's -7, right? So if you can write this as subtraction and tell yourself that the starting point is at -7, you're okay. But some of us might need to rewrite it as plus -7 to be able to tell ourselves that our y-intercept is at -7. Cool? Preguntas? Try. If you really want to challenge, move on down to D, E, F. If you're still getting comfortable, work through B and C. If you want to challenge, move on to D, E, F. Skip B, C. But if you are still working it out, do B and C. I'm going to do B up here, so don't look unless you need help. And if you skip it, wonderful. Just move on to D. You know why? It's systematic. It's like, it's the right brain, left brain thing. He's like, okay. Yeah, thank you so much. And there's 2 different envelopes. Like, I have one more for an afternoon teacher, or Mr. Smith might just do it. But they get sent differently, so you can go ahead and send that out. There's B if you need to see the work that accompanies. Oh, I have stuff to hand back. I should do that while you guys solve through those. D, E, F is your main priority. We're going to go over those here in just a minute. D, E, F, main priority. If you have not started on D, E, F yet, please go ahead and work on those. I'm going to put D up on the board here and just, actually, if anyone's confident enough that they want to show D, raise your hand and I will come check your work. And then, give me a sec, I'll be back, George. I'm going to clear this from up here. You got it. Now, show your in-between. Like, show the arcs for the multiplying. So, like what? Alright. So here, this is 2 times the value of y minus 3. So both of these have to be double. And if this was me, I have normal organization of my notes. So that might be kind of a little bit of a struggle. It's probably just on every go problem. What happens if you want to like we left a lot of open space over here? Yeah, I know, but what do you want to do? Okay, so I might advise you to get a 2-sheet of paper. So do you have more graphic? So write out the beginning. What do you want to do? I would start. I would fold
minus 3y is 1.
So go ahead and write down the parentheses y minus 3 equals 2x minus 3. So then you follow through
Minus
2 times both of those numbers. So 2 times the y, 2 times the 3. So that now George didn't change colors, which is okay because he probably didn't do that on his paper. But I would change colors if I was you. So if I was doing this, this step would have been in red, and then this step would have been in red. So look up here at George's solution. Are there any questions with what he did? He did the distribution of the multiplication. Then tried to get his -6 to be gotten rid of, or whatever you want to say there. So he added 6, makes 0, right? But when he does it to this side also makes 0, so we're left with just 2y, 2x. And if 2y equals 2x, then y must equal x, right? Because if 2's are the same, then 1's are the same. Gwendolyn?
I did it and I got negative y equals negative x.
You made a mistake somewhere. Wait, you said negative y equals negative x? That's the same thing. So if you apply a negative multiplication on both sides, it's the same thing, but here's the thing, you're not done. Because our done is getting y equal to something. So if you have negative y, negative x, that's right, but you're not done yet. We would then, on both sides, multiply by -1. And that makes y equal to x, just the positives. Yeah, we need to get to positive y to actually be done. Yes?
I have a question
For E, about to do that one. E5 minus 3 times x plus 1. 2y minus 3x plus 2. All right, what's your question?
Okay, so would you subtract 5 and 3 first and then multiply 2?
Order of operations.
So
So, amazing question here, and I know that hasn't really answered your question yet. So the question was, what do we do first, right? And even that is kind of a complicated, first. I have very strong opinions here. First, go figure, Hudson has strong opinions. First thing I do is rewrite it with addition. And there's a huge reason why. This looks like 5 minus 3 multiplied by x plus 1. It's not. It's 5 minus 3 times x plus 1, but all of this is going to be taken away. All of this is going to be a subtraction. So if I rewrite it as this is easier for my brain to say -3 times x, -3 times 1, and this becomes 5 plus, because guys, sorry, think through order of operations, parentheses, can't do it. I can't do x plus 1. Exponents, there aren't any. Multiplication, this is multiplication. So I can't add or subtract yet. I got to multiply because I have multiplication to do. Does that help clarify? So 5 plus, this becomes -3x when I do that multiplication. Plus, -3 times 1 becomes -3. I like addition much better than subtraction because subtraction is a lie. Actually, I seriously think I'm going to print off this debate that, not really debate, it's more of a discussion. But a teacher posted, hey, I'm teaching middle school math for the first time. He's normally a high school teacher. And he said, I'm trying to get my students to understand, and really what they were struggling with is, something like the idea of 5x minus 3x, and how if we think about it as 5x plus negative 3x, there's actually going to be 3 groups of 0 that are made here. Because, yeah, it's going to be 2x, right? Because 3 of them pair up and make zeros. And, like, it's really complicated if you learned the old way and you're trying to teach a new way with this whole, like, making zeros things, and, like, it doesn't really make sense full out. But it's interesting because it all comes down to your perspective, right? Of, like, how do I think through this? So now, I believe it's much easier to say, oh, 5 and negative 3. These guys can group up, but what's a 5 and a negative 3? A 2. And then negative 3x. Over here, y term, x term, constant term. There are no like terms. It just is what it is. What side does y have control of? The right side. Give it to y. Just give y the right side. So, how do I get rid of a negative 3x? Add 3x. Now, I'm scared to say this, but for the amount of board space that I have, I'm going to go ahead and say this, although I'm very, 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 very frightened. You can do multiple steps at once. However, that's asking to make a mistake. So, I know I got to add 3x and it takes care of those. But what I actually realized real quick is like, oh, well, that makes 0. And that makes 0. So since that was so easy, I'm going to go ahead and get rid of this plus 2 as well. How do I get rid of a plus 2? Or by adding a negative 2, right? Either way we could say it. Wait a minute. This becomes 0 equals 2y, which when I divide by 2, which we still have to do, right? I'm trying to get y by itself. This is not wrong.
Divide by 0 error.
That's weird.
But we're not dividing by 0, Quinn, we're dividing with 0. So it's when you put the 0 on the bottom, that breaks like the calculator and the math and whatever.
Why is that impossible?
Y equaling 0 exists. It is the line. Actually, can anyone tell me what is y equals 0? I'll offer up a piece of candy for this. When I draw my graph, what is the line y equals 0? Oh crap, now I have multiple. We don't know who was up first. Who haven't I talked with today? Simon?
It would be at the very middle of the graph
Okay.
where all of them interline together.
Okay. I'm looking for a 3-word answer, actually. You're right. Nothing that you said is wrong. But I'm trying to, like...
On the y-axis? Forward.
What?
Was that forward? Huh? Wait, you want a 3-word answer?
3-word answer.
Why is it
Mallory?
the order?
Quinn?
Y equals x.
No, that's a different line. Y. So we're saying y equals 0, right? Not y equals x. George?
Be a dot in the middle? No? Dot in the middle. Dot in the middle. Oh, it's just a line. X-axis.
The x-axis. Y equals 0 is the x-axis.
Oh, I get it.
Because it's every point on the x-axis has a y value of 0.
I got it.
So if I put arrows at the end of this, that is the line y equals 0. And it goes forever.
That makes sense.
Now, that then we can quickly, probably easily infer what's another way that we can talk about the y-axis, Mallory. However, here's the issue. If I try to write a y equals equation for the vertical line, we can't define that slope. Because if I look at the line that is on the y-axis, my y's is an infinite amount, or countable, doesn't matter, but my run is 0. we can't divide by 0. So for the line that is vertical on the axis, y equals 0, but for any other line, you can't really define a vertical slope. There is no, like, it doesn't have a slope because you can't divide by 0. I'm thinking that later this week we will try something, but I want to run like a test run. So by the way, does this process make sense, what we're doing with balancing equations?
Yeah.
Oh crap, now I don't have enough time, so I forgot about these problems. Real quick, in 5.4, this I think is this question. If it was asking you to solve for a specific variable, instead of like we've been doing solving for the y, like here it asks us to solve for x. So now what would be your first step if I'm trying to solve for x there? Remove the y, right? Give x that side, let him keep that. Remove the y, so I subtract 5y from both sides. I know I would change colors. 2x equals 10 minus 5y.
Not x, y.
Then what do I do? Anyway, divide, right? Get rid of that 2, divide by 2. So if we're trying to solve for a different variable, we just let that variable keep the side or whatever. Now, if we have to combine variables, like here I have x's and here I have x's, we just choose a side. Say, all right, I'm going to put all my x's to the left side, or I'm going to put all my x's to the right side. Like, you don't have a defined side that x has control of there. Yeah, Connor? It would equal 5 plus negative 2.51, because we have to divide both by 2. Right, so we divide both of those by 2, and it'll be 5 minus 2.5y. We're going to keep doing more with this, but I'm going to show you guys something. Kind of, but...
I have Desmond, but I don't, like, I haven't saved.
All right. So we're probably going to do this tomorrow, but I wanted to get like an intro with you guys today. So here's the objective, right? Get all the stars with the marble. Click launch. So this is what we're trying to do, right? Makes sense. So what do we think we need to do here? As we're starting to understand our y equals mx plus b and what things do, I need a hand. Who has a suggestion for what I need to change? Quinn?
Instead of y equals a half plus 1, make it y equals 1/2 x plus negative 1.
Somebody else. Give me a hand. George?
So instead of negative 1, it would be negative 1/2.
1/2?
No, not negative 1/2. Negative 1 1/2.
Negative 1 1/2.
No. 2 1/2.
Connor? 2 1/2. Do you want to keep 2 1/2 or you want to try 2?
2 1/2.
Yeah. Now, would 2 have worked?
Yeah.
2 would also work. Give me a hand. Somebody. You can start packing up, but we have like 2 or 3 minutes. Greg? Change what to negative 1? The 4, change that to a negative 1?
Wait, never mind. No. 1/2. Never mind.
Give me a hand. So this is what it started as.
No, 3 to negative 1. No.
Why do I still see no hands? Arcadia. 2x? What if I just get rid of it? Then, like, so if this was 1, right, that's still not good enough. Micah.
Replace the 1x with a half.
Well, replace the 1 with a half, right? Not the whole 1x. Because if you replace 1x with a half, sorry, so here's what you technically told me to do. Right, so I know what you meant. Heyo. So, Do you guys think you would enjoy working through something like that?
Yeah.
Okay, the couple no's, change your attitude before tomorrow, because that's probably what we're doing tomorrow. Have a great day, guys. Check out this one. Now the line stops. So this is what you'll have to figure out tomorrow, what makes the line stop.
I know. It's because X is less than 4. You have to remove that.
But do I really want to remove that? Because these aren't in a straight line.
Oh, you change it to X equals 3.
X equals 3?
No, not X equals, but X is 3.
I moved it left.
How about 5?
It seems like that might go.
Alright, get out of here, guys. You can try this tomorrow.
6.
Get out of here! Have a great day, guys.
I like this class.
I know! I'm leaving you hungry. Go figure.